the fundamental beliefs that we have at scale is that um, you know there's sort of like a few resources that go into producing really high quality machine learning systems. If you think about like what are the raw ingredients, one of those raw ingredients is compute. One of those raw ingredients is data, and then the last raw ingredient is sort of like human insight, so to speak, or like and sort of the process of producing annotated data is combining raw data and human insight together, and sort of mixing those ingredients together, and you know um, all AI systems of the future are going to be heavily reliant on human insight, even if we have incredible advancements in the technology, et cetera. Because at the end of the day, we're at minimum we're going to need oversight in these AI systems to make sure that they're producing the results that we would expect and producing the results that we think are make sense and whatnot. And so we think this like problem, this sort of like one of the core problems of machine learning is like, how do you make sure that for every problem that that you might want to solve using machine learning, you might want to have a machine learning system do, they're able to effectively get human insight to sort of like power that use case. And the way we think about it is twofold. I think first is for folks who are trained up, you want those individuals to have as much leverage as possible. So you want um, and this is somewhat circular, but it becomes very important. You want machine learning systems to do as much of the work as possible, and then really have humans spend all of their effort on almost quote unquote the edges, or on the really like high judgment work that's required that enables the utmost quality, while making them the most efficient in their roles. So that's the first piece, and the second piece is sort of this general education problem around how do you enable people to be experts, and how do you like train them most efficiently. And one of the almost funny side effects of solving this problem at scale is that I think we have one of the probably the more interesting ed tech systems out there, in which we have systems internally which track all the different kinds of, edge cases might be one way to talk about, but all the different kinds of nuances to some of these data problems, right? Like how, like this cilantro versus parsley example could be one of them, and the different ways in which you can tell, or detecting a melanoma versus other kinds of growths on skin. So there's all these different nuances, and we track all these different nuances within our internal systems, and we are constantly trying to understand for each of the annotators what is which nuances, or which edge cases are they performing well at and they understand super well, and which ones might be tripping them up, and then proactively serving them materials and content and examples that help them elucidate these cases that they might not understand super well. And so it's almost, I really think about it as an ed tech system which enables the enables people to really like quickly grok and understand all the nuances of the data. And humans are incredible at pattern recognition, right? If you think about what it takes to go through medical school, and you talk to folks who have gone through medical school, it's an incredibly long process of just sort of like continued pattern recognition. And that's sort of that same process where we try to distill for the annotators in our system to enable them to do great work.